Okay, so question 2 is Newton's. It's from grade 11, and I'm possibly wasting my air here, but you have to get the definitions right. So I've got the definition here, and they're asking for Newton's second law of motion. There are two different versions of it, but I'm just giving us the one that we normally look at. When a resultant force acts on an object, it accelerates in the direction of the force, and the acceleration is directly proportional to the resultant or net force and inversely proportional to the mass of the object. And you will see that certain parts of the definition are underlined. If any of those words are left out, you're going to lose a mark. So that is the important part of the definition. But if we can just learn the definitions word for word, that would really just make everything a lot easier. And it's 2 marks. For 2.2, it's 5 marks. 5 marks, 5 arrows. So we need to draw a free body diagram with 5 arrows. And now I'm just going to see if I can sort out something here. So here we go. There it is. And some of you get a bit stressed about this thing over here and trying to make it horizontal and things. Just make this little ball bigger. So by all means, draw it this big. So then you can easily do horizontal lines coming out like this. Because you guys do skew lines and then you get upset when you get it wrong. The forces are horizontal, so don't draw them skew. So this is 5 marks, and I'm just going to show you how they do it. So here's the 5 marks for the 5 forces. This one is not a good one. FAP is not a good one. It should be F applied. It shouldn't be FAP. And again, here they say they're accepting it, but there was 1 year when they didn't. So I'm not a very big fan of that one. But you can do FA or F applied or simply just F. Also, if you can take note, the weight is small w. It's not a capital W. Capital W is work. And friction is a small f. So this one would be better if it was FK. Again, they're not penalizing you in this one, but they could penalize you in the one that you get. So if you can be more specific, that would be better. The friction is always opposite to the direction that you're moving. And this example is moving to the left because it says so in the question. Okay, so everyone must be able to get those 7 marks. Those must be everyone's marks. And then what you do after this is you just leave out the rest of the question. Because you've gotten 7 out of, let me just check quickly, 7 out of 15. It's almost 50%. So in all seriousness, after this, you can go and often do something else. Do Doppler effect or electrodynamics or something else that's easier. But yeah, we should all be able to get those 7 marks. You must remember to draw arrows. So those lines, they can't just be lines, they must be arrows. And they also must be labeled. It's really nice if you can actually do a key like they did here. They're a lot more lenient if you have a key. So if you do an N and it doesn't look like a capital N or something, and then you put it in a key and you write next to it normal, they'll mark your key more so than your diagram. So you can actually maybe try and start using a key when you do a free body diagram, and then you're even more likely to get the marks because they mark the key instead of the picture. So sometimes your handwriting and arrows and everything get completely messed up when you draw these things in a hurry. But it's 5 marks, 5 arrows. And we need to get those 5 marks because those are also quite easy, actually. Then for the next question, we're going to have a problem. They want the kinetic frictional force on block A, and it's only 3 marks. So now, I'd actually like to, not introduce you, I've shown you before, but you may or may not have listened. There is a skew force here. So there's a thing. I've made another little Terry table thing where the force is skew or the floor is skew. If the force is skew or the floor is skew, you end up with a parallel and a perpendicular component. So if the force is skew or the floor is skew, you end up with a parallel and a perpendicular component. And if you can just remember the one, my little Terry table thing will tell you all the other ones. So the parallel component, if the force is skew. So in this example, the force is skew. So now I'm talking about the parallel component when the force is skew. This one over here, parallel component when the force is skew, that one is cos. It's F cos theta. It's cos because it's adjacent to the angle. And if you can do that, the other one is obviously sine. And when the floor is skew, it's W cos theta for the perpendicular one and W sine theta for the parallel one. So when the floor is skew, it looks like this, and you have a box over there and you have the weight. The parallel one, when the floor is skew, is W sine theta. The parallel one, when the force is skew, is F cos theta. So in this case, the force is skew. So we need to calculate the kinetic frictional force. And so I can just maybe show you on the memo if I can find it here now. Sorry, oops. Okay, let me just try something here. Okay, so this is moving together for some reason. There we go. So this is the one I want to look at, and I want to cover it a bit. So if we can just write that formula, and we knew we were going to use that formula because the question gives you mu. So if the question gives you mu, you know you're going to use this formula. The one that we write, that's on our formula sheet, is this one. So if we write that formula and then sub in the 0,35, we will be able to get a mark for it. So if we just write that formula and sub in a mark, in a number, we will be able to get a mark for it. And so without doing anything else, we can get 1 mark for that, which now makes us have 8 out of 15 for this question, which is now more than 50%. But the problem is with this question that the normal force is helped by the skew force. This component here, this blue one, I should maybe use a highlighter. This component here, the perpendicular component and the normal together, the normal force and the perpendicular component together are working to cancel out the weight. So the normal force is going to be, so I'm just going to write it up here, sorry, because it's on the memo, but it's quite confusing on the memo. The normal force, well, if you want to do it properly, the resultant force, the net force, the overall force in the y direction is equal to the normal plus the perpendicular component, which is F sine theta, plus the weight. All 3 of those. They cancel out completely because this thing is not moving up or down. F sine theta is 49 sine 50, and the weight is downwards, so it's in the opposite direction of the force. So I'm going to make that one a minus, and the weight is going to be 4,1 times 9,8, because the mass of this block is 4.1. And you can see that here, that's what they did, but they just did it all in one. So they worked out the normal force and the component all together in the same kind of calculation. So here, if I can just show you what they did. This piece here is this one here, and this piece here is this one here. So they did everything that I wrote there, but they just did it all in one piece, without looking at anything else. So if I carry on with that mathematically, if I carry on with what I wrote there, I get that the normal force, if I carry on with this, if I move this one over to that side and this one over to that side, I end up with the normal force being equal to the weight, which is 4,1 times 9,8 minus 49 sine 50, which is what they've just put in here into this formula in the place of n. So what they're doing is quite hectic, but you can work it out separately if you like. You can do it baby steps rather than all in one big lump like this. This memo is a bit intimidating, and then you get your answer of 0,93. And this is what I've been telling you. Normally, most answers have a range, so you can have, it varies. So if you put at least 2 decimal places, if you have 0,92 something or 0,93 something, you can get the answer right, because the range is between 0,92 and 0,93. At least 2 decimal places, and so there is normally a range for the answers, but preferably use your calculator without rounding off. You can round off your final answer only, and then you will get all the marks. So that answer there was quite tricky, but you need to try and remember this Terry table for if you have a skew force or a skew floor. And then we now need to do the big simultaneous equation one. I'm just going to pause for a bit and delete some stuff so we can have some space to look at it, because that question is basically guaranteed in your exam. You've been doing it since the beginning of grade 11, and you are going to have it in your prelim, and you are going to have it in your final. Guaranteed. So it's up to you to just make sure you know how to do it. Okay, so just to continue here, what we need to do as well, if we haven't read the question yet, so sorry I'm doing this a bit arse about face, but here is a 4.1, here is a 4.1, that's fine. Here is a 2.3, here is a 2.3, here is a 49, here is a 49, here is a 49, and here is a 50, and here is a 50. So the only number that wasn't mentioned, that was mentioned in the question and wasn't on the picture, is that one there, but we actually used that one there already in 2.3.1. That one was mu. So we've actually dealt with that already, so that one was mu. So now, most importantly, very important, most important, we need to write F-res equals MA or F-net equals MA somewhere, and sub in a mass. So you can sub in 2,3 times A. That will get you a mark. And honestly, we're just trying to get marks. I mean, we don't need to pretend that we're doing anything else. We need to get marks. And this is a 5-mark question. So if we just do this, we will get one of those 5 marks, which now makes us at 7, 8, 9, 10, 11 out of 15. And so that's really good. I think we should all at least try and do something with this question. And if we can just write F-res equals MA or F-net equals MA and sub in any one of the masses, we can get a mark for that. The other thing that's very important here is the direction. So if I want to say that this way is positive, because the system is moving to the left, it's nice to make left positive. That means that up must be positive. Because, and we need to watch very carefully here, up and left are the same direction. Up for this one and left for that one are the same direction. If I do the opposite thing, if I make that one minus and down minus, those two are the same direction. If you can imagine them, if they're on a flat surface, so if this was 4,1 and this was 2,3, that way is positive. It's up on the one going over the edge and left on the one on the table. That's a very important aspect of this that you're possibly going to get wrong. Left and up are the same direction. The only thing that the pulley does is change the direction of what's happening. It doesn't change the amount of force or anything else. It just changes the direction of the force. So if we can just look at what the memo tells us, you see here, you get a mark for writing F net equals MA. So I'm not even asking you to write any of those more complicated versions. Just this bad boy over here will get you a mark if you sub in a number at some point. Then we have this little mess over here. 4,9 cos 50 is it's the parallel component of F. It's this force over here. The parallel component of F is this force over here, and then there's the tension, and then this one here is the friction. You just worked it out in the previous example. So once again, the memo does this very quickly. It doesn't bother with trying to explain anything or anything. And they make the T negative. I don't want you to, but I have seen that a lot of you do it. I wouldn't make this T negative. I would leave it as positive. And then when I get to this point, I will make one of them negative. But what they've done here is they've made one of them negative already, and then they've just made the two statements equal to each other, equation 1 and equation 2. And you'll see here, once again, you have a range as an answer. The 2.3 times 9.8, I'm not sure if you're aware, but that is the weight. So if you just work out the weight, you can see there's a mark here for weight. There's a mark here for subbing in the mass next to acceleration and the mass next to acceleration. We can all do this. We can all work out the weight. We can all work out the component and then sub in what we got for the friction. We can do this. We can get decent marks for this. And then you only get 1 mark for doing all the simultaneous stuff. This one you can leave out. But we would be able to sub in MA. We would be able to work out the weight. It's just 2.3 times 9.8. We would be able to work out the component because we now know the Terry table. We can do this question. We can get more than 10 for this question, which is good. That's really good. And so then we can feel better about the ones going forward. We can get more than 10 for this one. We can get more than 10 for photoelectric effect. We can get more than 10 for electrodynamics. We can hopefully get more than 10 for circuits and electrostatics, both of them together. That's already over 40 marks, and you only need 45 marks to pass. We really could do better with these questions. If you just put a formula and sub a number into the formula, we're going to get 50-60% for physics.